What is the abbreviation of VLSI? So VLSI is nothing but a very large scale integration is used to implementation of smart electronic ICs like microprocessors, ARM controllers and sensors. Everything are related to either AI and IoT design. So why we can go for study the VLSI design? That is the first question. So nowadays electronics device plays a major role in our day-to-day life. At the same time, we are facing one of the main problem is power dissipation. So we can reduce the power dissipation of electronic devices. We can reduce the power dissipation of in generally. So like that, we can choose the VLSI design. We can implementation or fabrication of effective way of electronics. So that is the need for we can go for VLSI. So the content of VLSI design as for JNTU-A Anantapur. So the contents of VLSI design total course divided the 5 units. In that first unit will cover the introduction to IC fabrication. So introduction to IC fabrication, what is the fabrication procedure, what are the different steps we have to follow in order to fabrication, and CMOS fabrication, NMOS fabrication, and finally PMOS. So these are the related to the CMOS. Next another you can study the BiCMOS fabrication also. Okay, so all related to fabrication will cover in unit 1. Along with MOS transistor characteristics like electrical characteristics like IDS, VDS, what is the IDS expression for MOS transistor, figure of merit, IDS and VDS, like that we can go for all cover in first unit. Coming to the second unit, VLSI circuit concepts and design process. So VLSI circuit concepts in the sense what are the internal resistance and capacitance of the MOS transistor. So how will it affect on designing. Next, design process means we can use implementation of design in terms of layouts and stick diagrams. So that is the second unit. Coming to the third unit, we can implementation of our circuits on gate level. So the basic building block of any IC or gates. So that is dealing with the third unit. So you can implement the logic circuits using the by using the gates. Next, physical design means it is coming to the second part of our back end of the VLSI design flow. So design flow will divide the two stages, front end and back end. So front end we can call as the all code related software. Back end we can call as the physical implementation process, that is called the physical design. Physical design divided into the 3 parameters, floor planning, placement and routing. Okay, once you can complete this, next to go for fourth unit, subsystem design and VLSI design styles. Subsystem design means, so in order to go for any complex application, so first we can divide the main application into sub parts. So that sub circuit we can call as the subsystem. We can call as subsystem. So like we can take the microprocessor. Microprocessor consists of ALU, control units, timing and units, registers, like that. So ALU is one sub part. Once again, ALU is also divided the multiplier, adders, counters, comparator, and increment and decrement. Like that, each and every part we can treat it as the sub parts. So finally, combining the all sub parts, we can implement the main parts. That is called the subsystem. So next, second part of the fourth unit is VLSI design styles. In generally, we can designing any IC. We can use 3 methods: full custom, semi-custom, and programmable logic devices. So this is the these all we can details going through the in due course. Okay, next fifth unit, VHDL synthesis and testing. Synthesis is also after completion of the front end. We can go for back end. In back end, synthesis is the first part. Synthesis is the process of generating logical components from the based on the VHDL code. So the synthesis output is also called as netlist. Okay, so finally you can go for CMOS testing, or simply you can go for testing. So once completion of all the fabrication steps, last one is testing, to test whether the IC is working or not, to test whether IC is working or not. You have any faults occur, so like that you can verify the by giving inputs and verify the outputs. So that is called the testing. So that is the fifth unit. This is the content of VLSI design as per JNTUA syllabus. Okay. Next, go for in detail about each and every unit. So once all of you go through it, unit 1, the basic steps of fabrication, BMAS has already covered. So this is the syllabus for unit 1, 2 and 3. Okay. Next, go for introduction. So VLSI is the process of creating an integrated circuit by combining thousands of transistors into single chip. So VLSI is the one of the method we can implementation or fabrication of IC by combining millions of transistors. Okay. So that is the thing. So now we can go for whatever laptops or mobile phones, everything is designing based on the VLSI only. Okay, no? The VLSI trend will begin in VLSI trend began in the 1970s when the complex semiconductor and communication technology were being developed. So what are the examples of VLSI? Microprocessor, microcontrollers, ARM, Raspberry Pi. So everything all are designed by using the VLSI design. Okay. Okay. Next, why you can go for VLSI design? So already I told that why you can go for VLSI design. So in order to fabrication of any IC based on the VLSI, we have the following improves are there. In that, first one is high speed of operation, low power consumption, and physically smaller, and improves the system performance, and reduces the manufacturing cost. So that's why you can nowadays VLSI is the tremendously plays the major role in electronic industry. Okay, so that is the thing. Next, go for before going to the in detail about VLSI, just you can know the history of electronics. In 1950s, so this total electronics is divided into 5 generations: first generation, second generation, third, fourth, and fifth generation. In first generation, the all electronic equipments are implemented by using the relays. So relay is a electromechanical contact, just like act as switch. The first computer implemented by the Charles Babbage, at the time the computer will occupy the at least 30 feet. It will occupy at least 30 feet length and width. Because of the relays will have more size and the power dissipation also very huge. So that's why. But at the time it is very completely useful. But day-to-day technology will be changes. Next generation vacuum tubes based generation. In this vacuum tube is nothing but just like a pipe. The electrons flow from one end to another end. Like that, we can use the all designs we can implement it by using vacuum tubes. Next, our main electronics engineer, the main aim is to reduce the size and to reduce the power dissipation and increase the speed of operation. So day to day the technology will change, research going on. The third generation came into the picture when the semiconductor devices came into the existence, and the electronics industry tremendously changes into the smarter way. So like that, we can improve the all electronic devices based on the semiconductor device like diodes and transistors. So even though the semiconductors plays the major role, but still you have to improve the electron device. Then you can go for fourth generation. Fourth generation nothing but IC based designs. So all our components are integrated with a single chip, that is called the IC based. The size of electronics industry tremendously changes into the low. So that is the fourth generation. Next, coming to the fifth generation, that is called system on chip design. System on chip design. So system on chip means, so IC means components are integrated in a single chip, but in case of a system on chip means different ICs are all integrated in a single chip, that is called the system on chip. So that is the system on chip. Next, based on the integration count, the chip integration levels are classified into the 5 different types. In that first one, small scale industry integration, medium scale integration, large scale integration, very large scale integration, ultra large scale integration. So in the early days of IC technology, we can use SSI. Later on, we can use the MSI, LSI and VLSI. Present we can go for VLSI. In future, you can get the VLSI also. Okay, this is the also very important integration levels. In SSI only you can integrate up to 10 gates. In MSI 1000 gates. LSI 10. VLSI 10,000 to 1 lakh transistors are integrated gates. Ultra large scale more than 1 lakh gates are integrated with a single chip. This the advantages already the why you can go for VLSI design or nothing but advantages of VLSI design. Suppose you have any IC designed based on VLSI, we have the following advantages: smaller size, low cost, low power, high package density, higher reliability. Reliability nothing but lifetime of our design. Next, now the present trend in VLSI is system on chip. System on chip is an IC in which all components are needed for a computer or other system are included within a single chip. So now all MI phones, Samsung phones and all are used for the system on chip configuration. Due to this, only the size of for mobile phones are tremendously changes into the small way. So this is example for SoC, Qualcomm Snapdragon 200. So this is the IC. It consists of all individual modules. CPU is the one IC, Arduino, GPS, Wi-Fi connection. So all are inbuilt within a single silicon wafer. That is called the system on chip. So now, what are the applications of VLSI industry? So VLSI, we can't find out we can't find out the area without VLSI. So there is no space without VLSI applications. So we have home applications in the sense TV, AC, refrigerator, mobile phones, computers, all the mobile automobiles, in-car, driverless cars, everything will be covered by the electronic sensors. Wireless communication, wired communication, and DRDO, military applications, satellite application, medical applications, like that, all everywhere we can use the ICs. So what are the softwares are used in VLSI design? This is the one of the most important thing, synopsis. There are mostly have only mentioned here 5 softwares. So many softwares are available. So in that the first topmost softwares are used for implementation of ICs. Those are Synopsys, Cadence, Xilinx, Altera and Microwind. These are the most top 5 softwares are used for implementation of VLSI design. Okay, this is the brief introduction about VLSI design. Okay, thank you one and all. Thank you.